problem. Draw two rectangles that each have a perimeter of 18 units, but different areas. Just drawing two, oh my goodness, here I go again. Sorry about that. Two rectangles, and they have to have a perimeter of 18 units, but different areas. So I'm going to draw some common rectangles I saw on your papers to use for our examples of what you should be looking for. Now, a very common one I saw was a rectangle that was a 1 by 8 rectangle. 1, 2, 3, 4, 5, 6, 7, 8. And another very common one that I saw was a rectangle with a side length of 4 units. 1, 2, 3, 4. And a side length of 5 units. 1, 2, 3, 4, 5. Okay. These are just two examples. Now, pretend you're the teacher and I just turned this exit ticket in. Thoughts? Megan? I see an area on here. Juliana? I don't see an explanation on here or any way to show my reasoning on here. Liam? I don't see any labels. Okay, all of these things, very small things, but add them together, and it's really big to miss all of these things. So, the first thing, the smallest first step I need to take is what Liam said. What do I need to do? Label the side lengths. Thank you. So we said this was an 8 by 1 rectangle. So I'll label this side as 8. Not just 8 though. Units. Because remember, perimeter measures length. Units are a straight line. So I'm going to write 8 units. And right here I'll write 1 unit. Okay? For this rectangle, we said this was a 4 by 5 rectangle. So for this side length, I'll label 4 units. And I'll label 5 units here. This is the very first step in your labeling. So when I pass your exit tickets back, the only thing I want you to focus on is, did I label? If you didn't, what is your job? To go and label it. And maybe you did label it, but maybe you didn't include units. So your job is to check that you even wrote units. That is our first step in revising our exit tickets. Please return your seat, thank you. I'm passing them back. Now, I don't have any feedback written on these this time, but that's just going to make you a better self-assessor because you need to find your errors based on what we are talking about right now. Okay, did you check the while you were out bin? Did you check the while you were out bin since you were absent? Did you check the bin? Because this is something you could do with us. Go check it. It should be in there. Okay, your job right now. Just gonna make sure that your rectangles have those labels. Sorry, some of y'all were like, make sure you have your labels. You got your labels? We're going to talk about that. You're self-assessing. And you have your numbers, but is that a complete label? Yeah, remember to write units. Okay. Our next step. So we've labeled. That's part of explaining and showing our reasoning. Well, I'm going to go back to the instructions. instructions and look at what was important. So draw 2 rectangles. I did that. Check. That each have a perimeter of 18. Did I do that?
Yeah.
But how do I know I did that?
You can add 2 sides and then 2 sides in the middle that have to be the same thing. When you add those sides together, you have to make sure you get
I need to prove it. I need to show that this rectangle has a perimeter of 18. I need to show that this rectangle has a perimeter of 18. So let's do that. Now walk me through this first one. Let's remind ourselves. How will I find the perimeter of this rectangle?
You can add the 2 sides.
Okay, so I'm going to add the 2 sides. What are the 2 sides?
8 and 1.
8 plus 1. And after I add 8 plus 1, what am I going to do?
8 times 2.
I double it, right? So I'm going to write times 2 is equal to my perimeter. Well, 8 plus 1 is?
9.
And when I double 9, I get 18. So my perimeter is equal to 18. 18 what? Units. So I proved that this rectangle has a perimeter of 18 units. I'm going to do the same with my second rectangle. You should be proving right now with equations that your perimeters are both equal to 18. Go do that now. Yeah, if you didn't finish, now is the perfect time to do that. So you did this one. You need to do this one too. Show me that this perimeter is equal to 18. 18 units. You prove that both of the perimeters are equal to 18? Or what are you finding? What are you finding? Why? Okay. So, because you're adding those together, and you're like, wait a second, when I add that together, I get 10, and then I double it, I'll get 18. Okay, that is why we should have our perimeters figured out too, because that's going to help you find any mistakes that you might have made.
I did right, but I just did.
You labeled it incorrectly. Is that what you're finding? Okay. I think you might have counted the dots instead. But what about this one? 5 plus 6 is 11, and then we double that. Do we get 19? So what does that tell you about your side lengths? What about you? Oh, never mind. You're good. Oh, was it, you wrote the wrong number? Okay, so go through these perimeters, just like I did on the board. Okay, did anybody find something kind of interesting when you went and found the perimeter of your rectangles?
Yes.
Like, was there anything that you were like, maybe this isn't right? Did anybody find a mistake that they might have made? It's okay to admit you made a mistake. Lena. So you added a whole nother, so what was your rectangle? Okay, did what? Oh, but you had drawn a 3 by 7? Okay, so by finding the perimeter, you're realizing this doesn't have a perimeter of 18. So that is also why it's so important to prove it. Because that's you checking your work and making sure your rectangles do have a perimeter of 18. Maya.
I also made a mistake during my time on the exit ticket. I did a 3 by 6, but when I went to do the area, I also added up to 18.
That's okay.
So that I realized you have to like check and like make sure they have different perimeters and characters.
Well, you can have a perimeter and an area that match.
Yeah.
That's okay. The purpose of this was to have the same perimeters on both of these, but different areas on both of these. Okay, one more, Joseph.
I have 60 having to do the rectangles. I accidentally explained why rectangles are the same thing.
Oh, okay. Okay, so we drew two rectangles. We know they each have a perimeter of 18 with different areas. Did we do that?
Yes.
Well, I did it, but do I know they have different areas?
No, but I don't care.
Remember yesterday we talked about you can't just look at it and know that they have different areas.
You have to show that you know.
You have to show that you know. Okay, so how am I going to show what the area is for this 8x1 rectangle, Grayson?
So you can, like if you know your ones facts, you can be like 1 times 8 is 8. So the area, or you can just split the.
Well, let's just go back to the basics. How would I calculate area for this?
You would do 8 times 1.
Yeah, because I'm saying length times width is what my area should be. So 8 times 1 is equal to 8. So what's my area for that first rectangle? The area is equal to, thank you for saying square units. I can abbreviate square as cube. I'm going to do the same thing for the next one. Just like Grayson said, we're going to multiply length times width to get my area. I'm going to multiply 4 by 5, and I get 20. So the area for my second one is 20 square units. Go find the area of each of yours, and then we'll discuss it. Make sure you've proven to me that those areas are different. Did you find your area? You have. Make sure you make square units though. Yeah. How are you doing, Julia? That's okay. Just write around them. You can write through them. Okay, so you found your perimeters. Now you're finding your area. How will I know if they're different areas? Are mine different? Use mine as the example. Are my areas different?
Yes.
Why are they different? Amelia.
Because the perimeter, like the units of the perimeter, yeah, the side lengths. The side lengths, you just have to multiply those, and that gets your area.
But looking at my areas, how do I know that they're different?
Because
Is 8 the same as 20?
no.
Okay, so they are different. You should be looking to make sure your areas are different. Now these are not the only two rectangles I could have drawn. Let's go through our steps from yesterday of how I could have figured out all of my rectangles possible with this perimeter. My perimeter is 18, so what was my first step?
Divided by 2.
Split it in half. 18 divided by 2 is equal to, so there's half of my perimeter. So what is my first combination?
1 by 8.
1 plus 8, that equals 9.
Yep.
What's my second combination?
2 by 7.
That equals 9. What's my third one?
3 by 6.
That equals 9. What's my fourth one?
5 plus 4.
Is it okay if I say 4 plus 5? I'm trying to go in order. Yeah.
Yeah.
And then what's my next one?
5 plus 4.
So if I wrote 5 plus 4,
I've
already written that.
So 6.
so these are your 4 rectangles that you could have drawn. If you have a 1 by 8, give yourself a check. You should have already checked it really, so you would know that that's correct. If you have a 2 by 7, that is correct. If you have a 3 by 6, that is also correct. And a 4 by 5 is also correct. Any other rectangle would not have a perimeter of 18 units. Once you have added what is necessary to get full credit on this. That's your labels, your proof of your perimeter, your proof of your area. Put this in your binder. This is, well, it says to explain or show your reasoning, so I just feel like this is a lot with the showing that it is explaining, but if you explain with words, that is excellent. Put this in your binder. This is a great study tool for our quiz that's going to occur next week. And you need to get your math book out to get ready for lesson 12. Yes, but you know when it is. It is not happening right now. Don't worry. Just one more time. I will not let you miss it. I promise.
Tell me, because he asked about now, they're going to come and get us.
They're gonna get it. Don't you
They're,
worry.
the parents are.
I don't want to tell you the exact time because if they're late or something, I don't want us to worry because it is happening.
They're coming to get us.
You should have your book on your desk. In 5, 4, 3, 2, 1. So today we're going to explore rectangles with the same area. This reminds me of something. Thinking back to yesterday. What was yesterday's lesson about? We explored rectangles with what? Different areas, but same perimeter. So what are we going to be doing today? Okay, let's see. We're on page
58.
Thank you. You're on page 58. Sorry. Trying to see if it was working. It is. You can take about 30 seconds, maybe a little bit more, to solve these problems. What do you know about this? For this. Divided by 4 is equal to 10. Okay. Now I'm going to walk you through this instead of going through the answers because this one took a little bit more thought. Okay, how can I use 40 divided by 4 equals 10 to help me solve 60 divided by 4 equals 10? Kate.
40 is 20 digit, like 20 numbers lower than 60.
So I think you're saying if you added 20 to 40, you get 60. Is that right?
Yeah.
Okay.
And then so if it's adding 20, then you add 20 to the total of 20 divided by 4, which gets us to 30.
So you're saying this should be 30? Let's think about that. We divided 40 by 4. So 10 4s equals 40. We have 20 more we need to divide by 4. How many 4s are equal to 20?
Oh, 5. And then you add 5 and 10 to get 50.
Yes. So we're just breaking that 40 up, that 60 up into numbers that are easier for us to divide. Well, I know 40 divided by 4 equals 10. And I know 20 divided by 4 equals 5. So what is 60 divided by 4?
52.
It equals 2. 15. Isn't that cool? Okay. So think about the next one. 80 divided by 4. I'll give you another 10 seconds to think about that one. So you can either revise your thinking. How can I solve 80 divided by 4 using one of these facts? Callan.
Well, I'm kind of thinking the same thing. I still can add 20 to 16 to get 80. So 20 divided by 4 equals 5. So add 5 again.
And what do we get?
20.
Uh-huh. What else could I have thought of? That was excellent, Callan. That's building on our learning from the first one. But I could have thought of it in another way. Mercy?
Well, since 80 is just double 40, you could just double 10.
80 is 2 40s, she says. Well, she says, I think this is what you're saying, right? 40 divided by 4 is equal to 10. And we have 2 of those now.
So that's 2 10.
2. Exactly. Sorry, I already forgot I had the answer there. Okay, so how can I solve 96 divided by 4? Carson.
We can use the problem 80 divided by 4. So basically, I got 80 divided by 4. I know that equals 20, right? So then I realized 80 plus 16 equals 96. And then I divided 16 divided by 4 equals 4.
You divided 16 divided by 4?
Yes. Then
Because we're divided by 4 each time.
Yeah, but you said you divided 16 divided by 4. Yeah, it's okay.
Well, it's just making sure he's using the word divided by. Okay.
what you do? Then after that, I added the 4 plus the 20, and then I got 24.
Excellent. I love that you were saying I used 80 divided by 4 to solve this. And I got 20. And I just needed to divide 16 more divided by 4 to get that 4 groups. So there are 24 4s in 96. Did you have something to add, Elliot?
Well, you can also, since 100 is 4 more than 96, and 100 is 25 fours, and you could just subtract 1 from 25.
Oh, I should have said divided by 4 equals 25. Sorry. Let me start over. So you're saying 100 divided by 4 is equal to 25, but it's 1 less 4? Is that what you're saying? So minus 4 was equal to 96. So you're saying minus 1 here, so that's 1 4 is equal to 24. I like that way, Elliot. Really good thinking. Really good thinking. So it's
I was wanting to say this, but I kind of did it like I knew 40 divided divided by 10 equals 20, and then 20,
40 divided.
and then 10 divided by 2 equals 5. So
for the first problem?
yes.
Oh, you split 40 into 20. Is that what you're saying? Into 20? Gotcha. Okay, so you did 20 divided by 4 and 20 divided by 4 to get your 10. Gotcha. I like that too. Okay. We're moving on with our activity. Area of 24. Okay, today we're going to understand area and perimeter of rectangles. First, you're going to work independently on the activity, similar to yesterday. You're going to have some partner work time, and lastly, we're going to share our work during a class discussion. We're on page 59. I'm going to give you 2 minutes to draw some rectangles that have an area of 24 square units.
Units.
Look, I'm doing it too, Carson. Sometimes we repeat ourselves. We just want to make sure it's there. That have an area of 24 square units, just once. Now, what does that mean? Area.
Oh, look at the inside of
The amount of squares within a tile the rectangle. How do we solve for area? What did we say earlier? Hey, think about that. Length times width is equal to your area. So in this case, length times width is equal to what? 7. Thank you, Kate. case, your length times your width is equal to 24 square units. Take about 2 minutes to draw your rectangles with an area of 24 square units. I'm going to set my timer. Love to see those labels and proofs, dude. Love to see those labels. You can label with your units. Good job, Leah. So you can hand and see the pencil bucket on there. Make sure when you're labeling the sidelines, you have the unit also. Okay. Put it right here, maybe say you have your unit. Perfect. So just worry about it. You know, that's fine. You can have it. Now remember, units. Label sidelines. Really love the labels, and I love the equations. We write units by these just so we're being a little bit more specific. And then, okay, I just wanna make sure we're writing units. Make sure you have units right. Prove your area. Okay. Now, something to think about. Did I label? Get back to your exit tickets. Did I label and did I have units? And did I prove what the problem said? That my rectangles have an area of 24 square units. Because when you're working with your partner, you need to check their thinking too. You're going to share your rectangles with your partner and see if there are any other rectangles that you can think of together. Then find the perimeter of each of your rectangles. Any questions about what you're doing with your partner? Okay. I'm going to set my timer for about 3 minutes for you to discuss. You can begin. You're saying square units, but you're not really. Okay, I actually don't want to say. Cal, share yours for a second. What do you think about what is the area of a 5 by 7? See if your partner can help. What's the area of a 5 by 7? Okay, the area needs to be what? What do we think our partner was doing with 6? So this is yesterday's lesson. Yes, that would have a perimeter of 24. But they all have different colors. We're looking for area. Okay. So we're gonna have to think different. We're thinking of not what number to add. Think of your factors and points. Oh, happy to hear that you checked it and found a mistake. That's awesome. Okay. This looks good. Why don't we use what Alex said, because he found it. And then you need to also find the parameter. Good point, Elliot, and we're gonna talk about that. Okay. Did you add, it was you, Lexi. Lexi, come show us your book. Lexi's gonna come show her thinking for this problem. She's gonna explain her thinking, okay, Lexi? I'll help you set up. Okay. I'll hold it. You wanna like stand by the board and point it at it. Sorry, Lexi. Let's just show from there, and then let's have to push it down.
I was thinking maybe like 4 and 4 by 6, because I know 2 times 6 is 12, and I know 12 plus 12 equals 24. Then I added.
So that's all to say that 4 times 6 is equal to 24. How many units? Not
Square units.
Square units. Can I add that for you real quick? Okay. That is different. Okay, continue.
Then I added 4 plus 6 twice, and I got 20
For what?
for the parameter.
Perimeter. 20 units for the perimeter. Okay. What other rectangles did you find, Lexi?
I also found 8 times 3. I knew that 7 times 3 is 21, and if I add 1 more 3, it's 24.
I should be on the board. I should be on the speaker.
And
Okay.
it's kind of hard to explain.
Okay. Just tell us how you figured out these 3 rectangles. Like,
So I multiplied 7 and 3, because I broke 8 into 1 and 7. And I knew that 7 times 3 is 21. Then I added 1 more 3 to get to 24. And that's how I got the area of 24 units.
okay.
And then I added 3 plus 8, which is 11, and I multiplied it by 2 and got the perimeter of 22 square units.
Not square units, just units for perimeter. Remember, perimeter is a straight line. That's okay. It's confusing. We're still practicing. And then areas is where to fill it in. Okay, what about this last one?
So I know that 2 times 12 is 24. So 24 square units. And I added 2 and 12 and got 14. And added 14 and 14 and got 28 units for my perimeter.
If you have a 4 by 6 rectangle, Lexi just proved to us that that is equal to 24 square units. If you have a 2 by 12 rectangle, she just proved to us but that has an area of 24 square units. Same with our 8x3 rectangle. She proved to us that that has an area of 24 square units. The only thing we're missing here is our unit labels on the side, but other than that, she's got the proofs, she did the work, she showed that they all have the same area. But what are we noticing about our perimeters?
Oh,
Amelia.
they all equal 14.
All of the perimeters?
No, wait, no. No.
That's okay.
The two sidelines that we didn't
What do you notice about all of these perimeters? Murti,
They're all different.
they are all different. Now, what else do you notice maybe about a certain rectangle and a certain perimeter? Is there anything else worth mentioning? Amelia?
Okay, so you can't do one of the rectangles because there's not enough room.
Wait, hold on 1 second. We're talking about just these rectangles. We're gonna get back to that in just a second. Like maybe, let me guide you thinking a little bit more specifically. Which of these has the largest perimeter?
2 by 12.
This one.
Yeah.
Which one has the smallest perimeter?
4 by 6.
This one. So it's like the longer one has a bigger perimeter. Now, I want you to think about why that could be. Why would this one, same amount of squares that are making up these rectangles, but why are their perimeters so different? I mean, that's 8 units different. Maya.
Well, because if it has like a big number, then you would have to like spread it out more. And for the perimeter, you do both sides. But each half is like equal. So then that'll be a bigger perimeter because you have like a bigger number. Like the more it's spread out.
Yeah, like more squares are making up this side length.
Yeah.
It doesn't have more squares in the rectangle, but more squares are lining up along this side than in this one. Meaning that we're using more of those side lengths of the squares in our perimeter. So I want you to think about another rectangle. Which one were you trying to tell us, Amelia? Why don't we have a 1 by 24 on here? Simply because it couldn't fit. But that is another rectangle we would draw.
Yeah.
Now, think about the perimeter of a 1 by 24 rectangle. You're telling me it's too long to fit on there. Do you think that perimeter is going to be larger or smaller than our 2 by 12? Larger. Larger. Think about it. Every square, you have one row of 24 squares. So we're using side lengths from each of the squares. Yeah. But when you look at our smallest perimeter, there's squares in the center that aren't even on the outside. That's why. Okay, thank you. These squares within, their side lengths aren't even around the perimeter, causing it to have a smaller distance around. Just something to think about. Okay, thank you. So I did have some questions as I circulated around. Some of you were saying, is this all I could draw? Because a lot of us had 3 rectangles. Well, let's think about it. We said that the length times the width should equal 24 square units. Well, y'all told me already, a 1 by 24, that's equal to 24 square units. What would be my next one I would try out? I would say 2. 2 times the number. 2 times 12 is equal to 24. My next one is 3. Does 3 work? Yeah, 3 times 8 is equal to 24. My next number I'll try is 4. 4 times 6 is equal to, the next number I'll try is 5. Why can't I do that, Mercy? There is not a number times 5 that gets me to 24. So I would try 6, but I've already done that, which means means
Four is the last one.
4 is the last one. So how